right now it is not at home. It is better you keep it at home before you run it. So down here, that's it, and you just check. So if you run it, actually you can see the displacement changing also. See? The sensing. So that means all everything is running properly. Okay, sensing properly. So just pulse. It's over. So connections are done. Okay. So that's now communicated with the Coke model, and we can stop it. That's it. Okay. Now you can start coding.
So I will
From the beginning.
yeah. So first
So this was just to initiate the communication. To check
Yeah,
whether
check all
communication
connections. So the problem is sometimes it happens. It will not communicate between the AMPAC and the shape table. So then there is some connection issue. So it will not sense the system.
just to verify.
If it is not, actually what happens is it will be, it has happened to me sometimes. So if it is so, you can actually check whether all these connections are proper, because it may get loose a little bit. All this drum power, or even this also. These two, if you check whether it is connected, even these three, actually.
Sensitive equipment, be careful, something like that. You should put it here. Because students
Actually
will...
speaking, students doesn't know, they have shown them only. I have not asked the students to work on this equipment at all. Because I know if they are working on this,
It will damage it, they will damage it.
So-
Yeah, that's why our people only, they will handle, they will just demonstrate them.
that is better.
Yeah.
This is working. Okay.
Okay.
Okay, now that if you understand that, then we will go to the next one.
Okay, stop it. Now you can close it.
So, then next one for whatever you made, this is there in this shape, in this interface itself. Okay.
So this is control, what was that?
Everything, like here, there is a definite response. Say, this is a, I will tell you.
can you go back on time first?
Regarding the sibling, I will discuss with you later.
Sure.
For this, for them, they don't need to
Yes.
actually work on this.
Yes.
So here there is definite only these inputs are there: sine wave, chirp wave, north ray check wave, core wave. All these four.
Let's go with sine wave.
Only sine waves, and we can control the amplitude as well as we can control the frequency.
Frequency.
That's it. That is more than enough actually. Okay. So if it is all fine, say just like last time, you just click here.
So you right now you given the amplitude is 1.
Not
Default.
Default. Okay.
Frequency is also one.
I have now it's actually started.
Communicating.
Okay. So some errors have happened.
I think it has touched, see the end. It has gone to the end.
What do you know why?
Amplitude is no.
We didn't start with the home.
With home. Okay.
Just
मैं शेयर कर दूंगा वो सर
हाँ, ठीक है, एक बंदे So we either this is red now, so it is at the extreme position.
now you can.
This one. So now once it is in the middle, this green light is there. It is at home. Now we can run this.
Now it is at.
So this was like Sudeep ji. This was like
See.
stopper on the UTM. When it goes too far away, it stops automatically.
Okay, so now it has started vibrating. Okay. So this is a measured one which we are entering, and this is a measured one which is there from that accelerometer.
Oh, that's
Checking the response of that accelerometer.
Both are matching, so no error.
And this is the current which we don't want. Okay. And this is the accelerometer scope.
What was that? We don't want.
This is the current which we are. This is the current ampere. This is the power actually.
Okay.
So this will give the voltage and this will give the current data. Whatever regarding the current. So it's an accelerating current basically. And there might be a lot of errors in noises in it. So we don't want this. So this is all we want from for our things. Okay. So this data we'll get, and also this is the acceleration response.
Sorry.
So this is the acceleration vector which we are getting from this one.
Acceleration 1,
This is stable acceleration and this is the floor acceleration.
floor acceleration 1, and second floor is not there, so it's a
This is
horizontal
that
line.
is that one which we have removed. Okay.
Second one.
Yeah. If you are connecting it, then you will get the response from this also.
Then 2 accelerometers,
Yeah.
2
So if you are
responses.
connecting somewhere over here and all connecting all this, it will give this response.
Okay.
Okay. So that is that. And if I want, actually, I can.
So
change
we are
it.
interested in this acceleration, right?
I will move. It will go on. Okay. See, this is why what the damper, mass damper has done. It will adjust itself so as to have not that much vibration. It is still vibrating, right?
But we have not yet controlled the damper anywhere.
No, it's there. We have control over this. This is the damper.
Here.
Here, it is automatic, so it is inbuilt in here. So
We don't have to control it.
no, this is an interface only for the table.
Table.
If the mass damper also comes, there is another interface also. Okay, just like this, I will show you. And
So
if you
we
want-
are interested in which of these signal, this one or that one?
Huh?
Acceleration 1 we are interested, right? Floor
Yeah,
1.
Only this one. We are interested in this one.
This is the input.
Input.
Okay.
So you stop by press the stop button or?
Which one? No, I didn't stop. I changed the shape from the side side. So now I have given this. So the table. So this is an earthquake data. Okay, random earthquake data which I have provided. So it is going like that. Okay. So anything at any, say till we stop, it will run. Okay. So if you are doing some fatigue testing, we can start with sine wave and make it run like anything till it fatigue. So we can extract the data accordingly as well. Okay, so this is the sine wave. So now actually you should also know that now right now it has okay. So right now we have not actually recorded any data. Okay, so if you have to record the data, you have to switch on this.
Export.
Okay, and create a file path also. Okay, it is better you create a file path. Let's say for example, maybe here. Slash grab dot txt. Okay, so create a file. Then
So like it will export from now, or let's say the
now it will
from now.
So until we stop it, it will keep on saving the data.
Yeah. So let me. So you have actually now I have created a file path. Now I have exported the data, and now I will. This is starting from home. Just check that everything is in home. We have actually we will start it. Okay. Now it will actually record the data as well as it will vibrate also. This has to be in a.
Okay, first you have to export it, then you have to
You
start.
create the file path.
Okay.
First. Then you click on this export, and then
And now when we will click on export again, it will stop
it
recording.
will stop recording.
So what is that sample time for recording?
I think in this one is to in 1 second it is like that I have to see.
Can we control that?
And actually I think no. In this right now we cannot. But if you are working with this like MATLAB interface, we can actually.
Yeah, that is
change the
fine.
sample.
We can obviously sample
This
data.
one we cannot change anything.
Fine.
This is for demonstration and all this experiment. But for other thing we can.
Okay.
Okay, so now I can stop it. Okay, that's it.
What's the maximum frequency we can go?
It will be 3 hertz in this, and two amplitude basically.
These are the limits.
Right in this, I'm saying again, this for this interface. Okay. And actually, trial is there. can decide all these things which floor acceleration, floor acceleration, floor 2 acceleration, table acceleration, motor current acceleration.
So our interest is in second last column.
Maybe, yes. And also time.
Time.
As well as input current also. Input one also, right?
Where is input?
Input acceleration, table acceleration. Will be the input.
Table acceleration. Okay.
Table acceleration, floor acceleration you can actually do it.
Can we save it like in Excel format automatically? No. Okay.
Actually, this you have in here we don't have Excel in it, so I didn't try it. But we can. It's a data, right?
No problem.
I think we can take it from Excel. We can write a small code for extracting the data also. And as for so like I said, this is for shake table review. So that one, like that, there is another for. This is the one. First, damper one damper. The same things are there. Actually, all these applications using manuals for working with this mass damper. If you want that also is there.
Mass damper means
Controlling this active mass damper.
controlling
Right
this.
now we have nothing apart from this table response table and this floor accelerometers. No.
That was automatically working.
Working.
It will adjust automatically.
Accordingly.
Okay, we won't play with this.
Yeah, then it is better not to do it.
That's not for the time being.
At least for this is better for the time being. For our purpose, this is more than enough. Okay. And
Maybe for some research purpose we can
yes.
do those things.
See, Simulink we have. So for example, we can do exact for that purpose. Actually, a little bit of preparation is required.
You can open any prepared file.
No, actually this is setup file because we need to run setup. So for this and all, we need to actually provide the inputs. So before we run the Simulink, we have to actually enter.
This is standard file.
Yeah, it is already prepared. So we can. So because we need to enter this. Enter what? Actually here KENC value we have to actually enter. So this is number, it is there. So once we run this, then we can work with.
So only zero value we are supplying.
No, actually here it says we can mount around 7 kg thing.
Where?
In this. 7
At
kg.
what location? Which mass is this?
No, it is the mass which we are mounting at the top of the table.
Okay.
Okay, so here this mass is negligible, so we are ignoring it. But if there is a significant amount of mass which we have to mount, let's say more than 10 kg or something like that. So I'll say for 7 kg we can reach a maximum acceleration about 2.5 g. We can vibrate at 7 kg. So accordingly, if the mass increases, the acceleration also decreases, right? The peak acceleration which we can reach also will decrease. So accordingly, so we can, if you need to calibrate the table, we can, if there is a significance. So this is for maybe we can work with for research purpose. So if you are mounting a mass, take 2 kg, 3 kg over the table, we can actually, accordingly we can adjust, and the response will also be likewise. Because if we are not giving it, the problem is the input one and the measured table responses will not be the same. It will be a little, so right now it is overlapping, no? So if you are not adjusting this, variation will be there.
Yes.
So that we don't want.
So right now we expect some variation because you have given value 0.
No, here there is no way. Actually, this way is
Still,
15 less.
theoretically some error will be there.
Yeah, theoretically.
But
That's why
minute.
that small.
Minute.
We can even see
Neglect.
that there is a small change between the two. Okay. So likewise, we can see we can create a sine wave here. Script is already there. We can create an earthquake wave here. We can evaluate the FFT from here.